I have a series of examples prepared for how to use the Coral agent skills inside of Codex. These are available to use today, so you can install them on whichever coding agent harness you want to use and just follow the guides here on how to invoke the skills and also take a look at the references to get an idea of what's going on with the skills under the hood and like what it's teaching the agents. So the skill itself is just a single invocation that acts as a router into this set of sub skills and references. So if you say some keywords, for example, relating to the Coral runtime, then it'll automatically route that request into this reference and teach the agent how to inspect the open API schema. Same goes for questions relating to setup. It'll teach it how to interact with the Coral server. And also from a more like planning perspective, you can ask it open-endedly about like agent communication design and topologies, and it will also be able to help you out there. So it's useful for both informational and implementation use cases. Best way to get a sense for this is just to try it out. So I would recommend installing and just asking your agent a few questions to understand how Coral works, and yeah, just get straight to describing some multi-agent systems that you want to and see how Codex handles using the skills to build it. But before getting into the examples that I already prepared, I wanted to go into a bit of theory first and just cover like the basics of what you'd want to know and like keep in mind when first getting started on Coral. So for starters, like a quick recap is that like the common shape of multi-agent systems today involve like setting up a workflow or structure for how the agents are gonna communicate or what messages they're gonna send ahead of time. This is what you'd see in any system that uses sub-agents. So like Claude Deep Research is a sub-agent driven system. Same goes for both Claude Code and Codex in their ability to arbitrarily spawn sub-agents. And simply put, how Coral fits into this is by providing these three core primitives, which is the ability to create threads, send messages into those threads, and await mentions from other agents. What you do on top of this is really dependent on the use case or application that you're trying to develop this multi-agent system in. But instead of building multi-agent systems as a static blueprint, you can build them in a way where communication happens more dynamically and agents themselves, each agent in the group has more autonomy over its communication flows. So what this looks like in practice is that you get access to or have the ability to build more niche kinds of agent topologies. So a few examples of these are dynamic coalitions, and you see this a lot in experiments, especially when agents are meant to mimic human teams where team formation happens more dynamically. Coral also fits into some patterns that are normally somewhat static. So for example, review pipelines will typically involve a handoff to have a separate agent review one agent's output, but with Coral, this can be something that you give each agent in a sequence access to. So if it finds something off, then on the fly, it's able to create the thread and mention the relevant agent that needs to do a review. The blackboard pattern is another fairly common one that Coral enriches quite a bit with staged or blocking negotiation phases in between blackboard writing. So the blackboard pattern is pretty much just giving agents like a shared database to write to, and from there they can like form different outputs or different conclusions. But with Coral, you can gate specific stages wherein agents are required to negotiate. That way you're enforcing that the contents written to a blackboard are actually being utilized effectively. But yeah, without going into like the specifics of like every possible topology, because that's more something that you'd be tailoring to each app and like use case. The main thing to keep in mind is that when you're building with Coral, The actual communication itself is sort of what's abstracted, and that's what we provide the tools for. So then what you're left with is thinking about the communication rights and agent responsibility. Because if you assume that all agents in a group have the tools to communicate with each other, then the important part shifts to specifying what each agent is supposed to do, which other agents they're allowed to call. And so yeah, that opens up a lot of flexibility in terms of the capabilities that you can extract out of an agent group. So I'm going to be shifting over into some of the more practical examples from here, and hopefully that will make some of these concepts click more. I wanted to start by showing what I would do if I was starting over, building something new with Coral, and then later on I'll also get into using the skills to work off of an existing application. So let's say that I wanted to use the blackboard and negotiation pattern, and let's say I also had a specific agent framework in mind. In this case, I'm going to be using this as an example. And then with the skills installed, I could just come straight into Codex and then describe what it is I want to do. So I'm invoking the Coral skills and also the built-in CLI creator skill. And what I want is a multi-agent deep research CLI that implements the blackboard and negotiation pattern. So agents are gonna have custom SQL tools, and then they're gonna receive the topic and then research different angles and subtopics independently, write their findings to the blackboard, and then a blocking negotiation phase is going to be in place so that the final output only gets submitted after it's verified that the agents themselves have went back and forth on their findings. I'm also cheating here a bit. This isn't completely from scratch. I do have some environment variables for my API keys. So for the test case here, it's going to be generating a markdown file off of this topic. And I'm also going to start by turning this freeform prompt into a specific goal. So here's the goal prompt. I'm gonna run this, and then the result we get should be the closest thing to a one-shot test using the Coral skills. So yeah, let's check in on that later. So here's what it came up with. Codex was able to set up the server configuration as well as the config files for all of the agents that are connected. It also implemented the custom SQL tools, and we can see that the CLI itself actually works. So I ran the delve skill, which you'll see is already installed, and these are the research artifacts that Codex was able to put together using the skill. So yeah, it's a pretty simple example, but it shows how quickly you're able to get something up and running using the Coral skills on Codex. The Coral agent skills are straightforward enough to get started with on Codex or Claude Code, but I wanted to put this together to show using the skills in a slightly more realistic setting where you might already have a project in place or some agents that you want to enable agent-to-agent communications with. So this is a CLI tool that I've been working on for managing the memories of other agentic systems. So right now it's being made to work best on Codex to start with. So I do already have a couple of coralized agents here, but the system itself is still running very sequentially through a set workflow with these 5 agents. So I have a goal prompt running here, which is going to show 2 things. First is the goal itself of discovering and implementing a new agent roster and update to the topology, which is deliberately non-sequential. And the second thing is just how effective Codex is in using the Coral skills to work inside of code bases and applications that are already using Coral. I'm going to check back in when this is done. So Codex completed the goal, and I also went ahead and added a skill locally to teach Codex how to use this new version of Refinery. So we can test it out with this prompt. So we can see that it's accurately referencing the skills, the relevant CLI commands. And here's where we can open up the Coral console to check out the session and threads that it creates. So now we're in the Refinery namespace that was created through Codex. So we can take a look at the session, and we can see that there's already a couple of messages that are firing off in this thread. The agents in Refinery their messages are formatted to this specific schema when it comes to extracting native codex memory. So they pass these sort of packets between each other, and then the codex agent itself is going to be responsible for formatting the output into a more human readable conclusion about what to do with the memory and any sort of updates that can be made to it. So here's what the final memory edit proposal looks like on Codex. From here, I would just continue using the Coral skills to improve the agent behavior, and then eventually get the version of the refinery CLI that I can package. Thanks for tuning into this walkthrough of the Coral skills. I would encourage everyone from here to go ahead and install these into your coding agent of choice and see what you can build with Coral.